Imagine you're in Antarctica. The temperature is far below freezing, and yet you can still get sunburn.
It sounds contradictory. How can you be freezing cold while radiation from the sun is still hitting you hard enough to burn your skin?
Here on Earth, we have an atmosphere, and we also have air and matter around us. Remove them. That's how James Webb Space Telescope has to work. Webb was designed to observe infrared light, so you can take pictures like this instead of this. What? Let me explain. As the universe expands, light traveling through it gets stretched. Light that originally left very distant galaxies at shorter wavelengths can reach us shifted into the infrared. That allows Webb to look incredibly far back into the history of our universe. But there's an enemy: heat. Now, Webb isn't actually going to melt.
Anything with a temperature emits thermal radiation, and the warmer something gets, the more radiation it emits.
Look closely at Stefan Boltzmann's law. Temperature is raised to the fourth power. So as the telescope gets warmer, its own thermal radiation increases very quickly, creating unwanted infrared background that can interfere with the faint signals Webb is trying to detect. So I wonder, how do we keep everything cold and running? The sun-facing side of JWST is much hotter than the science side. So how do you cool something that much in space? The answer is JWST hides from the sun. Webb has a 5-layer sun shield about the size of a tennis court.
The shield stays between the telescope and major sources of heat, like the sun, earth, and moon.
We think of space as freezing cold, but putting something in space does not automatically make it cold. But consider space is almost vacuum. If sunlight is constantly hitting the telescope, Webb could still heat up even while surrounded by a cold space due to the lack of convection. That's where the 5 layers come in. Each layer reflects incoming energy, while the gaps between the layers allow heat to radiate away into space instead of easily traveling toward the telescope. Together, the sun shield reduces the sun heat by more than 1,000,000 times before it reaches Webb's cold side, allowing instruments to work properly and refrigerator to cool down the camera so we can have pictures like this. And that's what I love about engineering. A place can be freezing cold and still receive enough radiation to burn you. A telescope can be surrounded by space and still not cold enough to work. Sometimes the smartest way to cool something isn't to keep removing heat, it's to stop the heat from getting there in the first place.